Hello everyone, this is Chetan Singhal. Welcome to my channel Stat Shine, where knowledge shines to make you shine. In this video, we'll be learning about graphical representation of numerical data. So the question comes that why the graphical representation is important. Suppose there is a student and we want to make him understand a story. We can either make him read or make him watch a movie about it. So in which case do you think that he would be able to understand it better? So most likely he would be able to understand it better while watching a movie because there he can see the graphics, the visualizations of a story. So in the similar way, here we see the visualizations that are created from the data, which are more easy to interpret, more easy to understand. So for the numerical data, the most widely used graphical representation is histogram. So we'll study histogram, which represents the distribution of data. So before that, we'll see one point. So suppose I draw this graph and try to interpret it. So can we interpret it practically? We can interpret it that this point y is increasing and then y is decreasing. But what is y? What is x? So before interpreting any graph, we should have clear understanding that what does x represents and what does y represents. Then only we will be able to interpret it practically. So we should be aware of both the axes, because at many places we see the graphs which are not labeled properly, so we cannot interpret them properly. So now coming back to histogram, which explains the distribution of the data. Suppose in a class of 40 students, I took a test of those students and I created the bins of the marks. So this is 0 to 10 marks. Here the variable of interest is marks, 20 to 30 and 30 to 40. So a 40 marks test. And there comes the frequency. So each bin contains 10 students. So we'll calculate the relative frequency. Relative frequency is nothing but the percentage, relative frequency in percentage of students in each bin. So here if we see, it would be 10 upon 40 into 100, that is 25%. This means 25% students fall in 0 to 10 category, right? So now if we make a histogram of this, so it would be 25. So this is relative frequency. Y label, we need to label it properly. X is marks. And here 10, 20, 30, 40. Then we'll draw bars which represents the height of these bars represents the relative frequency. So this is the histogram for this distribution of the data. What does the distribution of the data means? That how the data falls into each bin. 25% of the observations are falling into 0 to 10 marks. So this is one aspect of the distribution, that how the data is distributed in different bins. Here in 10 to 20 it is 25%. If we see 0 to 20, there are 50% of the observations. So these all are the aspects of the distribution of the data, and these are very clear from this graph. If we see, this is a uniform distribution. Uniform distribution means in all bins we see a uniform pattern. The bins are all height at 25%, 0 to 10. So if we see less than 30, so there are 75% of the students. So this is the very basic interpretation of histogram. Suppose we draw another, but here the frequency got changed. So here we take it 4, 12, 20 and 4. 0 to 10, 10 to 20, 20 to 30 and 30 to 40. So if we calculate the relative, so total students remains 40. So if we calculate the relative frequency in percentage, this forms 10%, this is 30%, this is 50, and this is again 10%. So making this histogram X and Y, which is labeled as marks, and this is relative frequency. So 10, 20, 30, 40. So this goes 10%, 10%, this goes 30%, this goes 50%, and this goes again 10%. So this is the histogram with this distribution. So this is a slightly different distribution as compared to the earlier distribution of the data. Here the bins were all equal, as each bin contains equal percentage of data, but here this bin contains maximum percentage of observation, this bin. So this is one aspect of the distribution of the data. So histogram captures that aspects, all the aspects of the distribution of the data. This phrase is used in the distribution of the data. This phrase is used in describing many aspects like skewness, kurtosis. In the upcoming videos, we'll be covering all those. So try to understand this distribution of the data meaning. So if we see 0 to 10, there are 10% of the observation. So combined, if we want to see that less than 30, there are 90% observations, and greater than 30 there are only 10% of the observations. So we can slice and dice with the data and see the distribution of it. So this is the purpose of the histogram. One more point, this is 0 to 10. We can make the bins more smaller, right? There are bins 0 to 10. The width of the class is, or the bin is 10. Suppose I made it smaller, so we will obtain a histogram something like that. This is a histogram which have a lot of bins, right? We can get a histogram like this. So this with relative frequency, and these as marks, and we can keep on just decreasing the size of the bin. So ultimately we can get this sort of curve for a continuous distribution of the data. What do we mean by continuous? Where the x value, when there is a mathematical relationship between x and y, then we can get a continuous distribution of the data. There are a lot of continuous distributions that will cover later, but as of now we just made it clear that this is relative frequency, y represent for the distribution of data, and this is the data or observation. So hope you have understood the meaning of histogram. So if you like the content and explanation, please subscribe the channel and like the videos. Thank you.